One morning in 2019, hundreds of Tesla owners woke up to the same problem. Their cars had lost up to 50 kilometers of range overnight. No accident, no cold snap, no battery failure. The battery was fine. The software had changed. I'm a battery engineer and I track these real-world cases for AmpCoreX. And this one exposes the part almost nobody understands. Your EV's usable capacity is not a fixed number. It's a setting. A setting the manufacturer can change remotely without asking you. By the end of this video, you'll know exactly how that setting works, when it's been moved down, when it's been moved up, and what you can actually check on your own car. Every EV battery has two capacity numbers. Gross capacity, what's physically inside the pack. Net capacity, what the software lets you use. The gap between them is the buffer, and that buffer exists for good engineering reasons. Sitting at a true 100% state of charge stresses the cells. So does draining to true zero. The buffer keeps you away from both extremes. It absorbs degradation quietly, so your range feels stable for years. It protects the warranty math. Here's the reframe. You didn't buy a battery. You bought access to part of a battery. And the size of that part is decided in software, which means it can be changed in software in both directions. May 2019. Tesla pushed software update to older Model S vehicles. The stated purpose? Reduce battery fire risk. That context matters. This was a safety response, not sabotage, but the method was a voltage cap. The update reduced the maximum voltage the battery could charge to. Lower maximum voltage means less usable energy. Less usable energy means less range. Owners reported losses of 32 to 64 kilometers. Court documents later confirmed the numbers. Roughly a 10% reduction for about 3 months, then around 7% for another 7 months before a corrective update in March 2020. 1,743 vehicles were affected. Tesla settled the lawsuit in 2021 for $1.5 million. Each affected owner received $625. 57 cars ended up needing battery replacements. The settlement resolved. The claims no wrongdoing was established in court. But one fact was now on the public record. A manufacturer had moved the switch down, and owners found out from their range display. Now the other direction, because this switch moves both ways. The 2019 Audi e-tron shipped with a 95 kilowatt-hour pack. Usable capacity, 83.6 kilowatt-hours. The rest was buffer. Years later, Audi pushed a software update. Usable capacity went up to 86 kilowatt-hours. About 20 more kilometers of range on a car people had owned for years. No new hardware, no battery swap. Audi's engineers had learned the pack degraded slower than their safety margin assumed, so they gave some of the buffer back. Same mechanism as Tesla's update, opposite direction, and this is the part the outrage coverage always misses. The hidden switch is not a scandal. It's how every modern EV works. The real question is who moves it, when, and whether you're told. Usable capacity is just one dial. The battery management system holds several more, and updates can turn all of them. 1. The charging curve. Your car follows a power map. High kilowatts at low charge, tapering near full. That map is software. An update can raise peak power or pull it back to protect aging cells. 2. Thermal limits. Software decides when the pack preheats for fast charging and how hard it cools in summer. Shift those set points and you change both charging speed and cell aging. 3. Regen. How much braking energy returns to the pack and at what temperature it's allowed. An update can soften it on cold mornings. 4. The range number itself. That figure is a calculation, not a measurement. Update the algorithm and your displayed range moves without one physical change in the battery. So, 2 used EVs, same model and year, different software, different charging speed, thermal behavior, displayed range. Identical on paper, two different cars on the road. One distinction decides what your car can even receive. Surface updates touch maps and screens. Firmware updates reach the control units, including the battery management system. The story isn't finished. In May 2023, a group of Model S and Model X owners filed a new class action. They allege software updates cut their range by up to 20%. Some claim they were quoted $15,000 for battery replacements afterward. Important word, allege. None of this is proven. In February 2024, a judge allowed the core claims to proceed, while dismissing several others, including the computer fraud claims. Allowing a case to proceed is not a finding of fault. It means the claims deserve examination. As of recording, no final outcome has been publicly reported. What the case will test is bigger than Tesla. When a manufacturer changes your car after purchase, what are they required to tell you? Here's my honest read as a battery engineer. The buffer is good engineering. Voltage caps after a fire risk are the responsible call. I would rather lose 30 kilometers than gain a thermal event. The failure in 2019 wasn't the update, it was the silence. An owner who loses range deserves to know why, in plain language, before it happens. Manufacturers that communicate buffer changes openly are showing you their engineering culture. The ones that don't are showing you something too. 3 practical moves. 1. Before any major update, screenshot your typical full charge range. That's your baseline. No baseline, no proof. 2. Read the release notes before installing. If battery or charging behavior is mentioned, note the version number. 3. Buying used, ask which software version the car runs and check the model's update history for known range changes. So back to that 2019 morning, those owners didn't lose range because their batteries failed. They lost it because a setting moved without warning overnight. Your battery's health is physical, but your access to it is controlled in software by someone else. This was AmpCoreX, battery intelligence for the electric age.